Hello everyone, in today's video we are going to learn about HCF, that is nothing but highest common factor. So to begin with, first we need to know what is a factor. So what is a factor? Some of us may know, but for those who don't know, factor is nothing but the two or more tables in which a particular number comes. For example, let's take 8. 8 appears in the table of 4 and 2. So 4 and 2 are the factors of 8. Similarly, 12 appears in the tables of 6, 2, 3 and 4. It also appears in the tables of 12 and 1. So these numbers are the factors of 12. So that was about the factors. So next we are going to learn about the prime and composite numbers. Okay? So prime numbers are numbers that only have two factors. They are 1 and the number itself. For example, 3. So 3 appears in only two tables, the tables of 1 and the tables of 3. So the number itself is nothing but 3. Right? So 3 appears in 1 and the number itself, that is in 3. Right? Next, let's see about the composite numbers. Composite numbers are numbers that have more than two factors, that appear in more than two tables. Like more than 1 and the number itself, it appears in other number tables as well. For example, 8. 8 appears in 1, 8. The tables of 1, the tables of 8. It also appears in tables of 4 and the tables of 2. Okay, so that is a composite number. So let's repeat. Prime numbers are numbers that only have two factors. They are 1 and the number itself. Composite numbers are numbers that have more than two factors. Okay, so this was about the prime and composite numbers. So next we are going to learn about prime factorism. What is factorism? Factorism is a process of finding the factors of a number. So when we find the factors of a number, that particular process is nothing but factorism. What is prime factorism? Prime factorism is a process of writing the numbers as a product of prime numbers. Okay, so when we write a particular number as a product of prime numbers, that process is nothing but prime factorism. So to do so, we follow a method called factor tree method. Okay, so let's have an example here. To begin with, we'll go for a smaller number and we'll use the number 8. So in the factor tree method, we use 3 steps. So what are those steps? The first step is write the given number as a product of any two numbers. Okay? So, can you name two factors of 8? When we divide those two factors, it forms 8? Yes, you're right. They are 4 and 2. So, they are 4 and 2. Okay? Now, the second step is look at the factors. Look at these factors. Okay? If any of the factors are prime, like if any of the factors are prime, circle them. Okay? So 2 is prime, so we can circle it. And if any number is composite, what do we do with that number? We further divide it. So can you name two factors of 4? Yes, you're right. They are 2 and 2. So as we can see, these both are also prime numbers and we circle them. So we continue doing this until we reach the end and there is no more numbers left to divide and we are left with only prime numbers. So the highest common factor of two or more numbers is the greatest number that divides the numbers exactly. We can find the highest common factor of two numbers by the prime factors. So as we saw, the prime factors of 8 are 2, 2 and 2. Okay, so we multiply them first. So the steps of finding the highest common factor is first, before that, let's see this. To check if your prime factorism has got correct, we multiply these. So always remember 2 into 2 is 4 and 4 into 2 is 8. So this is 8 and it is correct, right? Next, how do we find the HCM, the highest common factor of a number? To do so, first we need to find the prime factors of a number, of two numbers, two or more numbers. So first we are going to do it with only two numbers. Let's take the numbers 64 and 84. So we are taking the numbers 64 and 84. Okay, so what we need to do is do the factor 3 method for these two numbers. So let's do it for 64 first. Okay, so now for 64, can you name two factors of 64 that when multiplied together make 64? Yes, they are 32 and 2. 32 and 2. And you have guessed it right, 2 is a prime number, so we circle it. Now 32 can be further divided, right? So how do we divide 32? What are those two numbers? They are the numbers 4 and 8. Okay, so none of them are prime, so we should not circle them. Okay, so let's divide. 4 is equal to 2 into 2, those are prime, and 8 is equal to 4 into 2, where 2 is prime, and when 4 is further divided, it again comes as 2 into 2. Okay, so we've got all our prime numbers, and so the prime numbers of 64, as we saw, 64 is equal to, how many 2's are circled? 1, 2, 3, 4, 5 and 6. So 2 into 2 into 2 into 2 into 2 into 2. So 6 2's. Yeah. Now let's do the same for 84. So we can erase the factor 3 to save space. And let's do the same process for 82. 84, I'm sorry. So for 84, let's do it. So can you name two factors of 84 that when multiplied add up to 84? They are 42 and 2. 42 and 2. So 2 is a prime number, and when 42 is further divided, it goes into 6 into 7, right? 6 into 7. So here 7 is a prime number, right? Because it only appears in the tables of 1 and 7. That is the number itself. So 6 when further divided multiplies into 2 into 3, and so 2 and 3 are both prime numbers, right? So we've completed, and the prime factors of 84 are nothing but, you write it from the right and go into the left. So 2 into 3 into 7 into 2. Okay. Now the next step is to find any common numbers between these factors. So the second step is to find the common numbers in these two factors. So first there is a 2 here, and there is a 2 here too. So 2, and then so this is done. Next number is again a 2, and there is another 2 here. So another 2 we've got. Now this is another 2, but there is no 2 here. And if you look at the rest of the numbers, there are no more. So we've got our common factors. They are 2 and 4. Now how to find the highest common factor? To do so, multiply the common factors together. So 2 into 2 is equal to 4. So we got our answer 4. So 4 is the highest common factor of 64 and 84. Okay. Now, if you don't want to use the factor 3 method, there is another way to do this. That is the continuous division method. So, what do we do in the continuous division method? We take these two numbers, let's do the same numbers and see if we get the same answer. So, with the factor 3 method, we got 4. Let's see what do we get by the continuous division method. Okay, so let's begin. To do so, first write down the two numbers on the side. They are 84 and 64. Now divide the bigger number from the smaller number. So divide 84 by 64. Right? So 64 ones are 64 minus is equal to 20. Now we can't further divide it. So moving to the next step, we divide this number by this number. So we divide the previous divisor by the remainder. So let's do it. I'm sorry. Okay. So 64. So 23 is 60 minus is equal to 4. We can't further divide it. So if you guessed it, yes, you're right. We need to divide 20 by 4 now. So divide the previous divisor by the current remainder. 20 by 4. So 4 5s are 20 minus is equal to 0. So as soon as your remainder reaches to 0, you stop there. And the last divisor of your whole thing, the last divisor is your answer. So which is the last divisor here? 4. So as you can see, we even got the right answer here. Let's try for few more numbers. Okay? So with this also, we got 4. So it works. Both are correct. Okay, so the next numbers we are going to do this for are the numbers, let's think. Let's say we take the numbers 24 and 60. Good pair? 24 and 60. So what is the bigger number? 60. So 60 by 24. So 24 twos are 48. Twos are 48 minus borrow 10 minus 8 is 2 and 5 minus 4 is 1. We can't further divide it. So moving forward, if you guessed it, yes, 24 by 12. So this was a pretty simple one because 12 into 2 is 24. This is 0. So we reached and the answer for this one is 12. Okay, so we get it as 12. Now let's do the same with the factor 3 method. Yes. And let's see if we get the same answer. So which are the two numbers we picked? 24 and 60. So 24 when divided, if you guessed it, it is, 4 into 6. So none of them are rhyme. So 2 into 3 and 2 into 2. So circle them. So these are the prime numbers. And for the next number, that is 60. Let's do it. 30 into 2, 2 is prime. 6 into 5, 5 is prime. 3 into 2, that is 6. So we've got our prime numbers. Now which are common here? Let's write them down first. For this, it is 2, 2, 2, 3. Okay? And for for 60, it is 3, 2, 5, and 2. Right? So let's erase the factor trees. So let's see the common numbers. 2 here, 2 here. Can be crossed. 2 here, 2 here. 2 here, no 2 here. 3 here, yes. Right? So let's, any more common? No, right? So let's multiply them. 2 into 2 into 3 is equal to 2 into 2 is equal to 4 and 4 into 3 is equal to 12. So we've got the same answer, 12. So again, it worked. So here I have a task for you all and I want you to write the answers in the comments box down below. Can you tell me the highest common factor of 12 and 14? Do this and write it down in the comment box down below what is the answer. I'll be waiting for your replies. Until then, goodbye. Please smash the like button and subscribe to my channel if you haven't yet. Be sure to check out my other videos that are linked right here and left here. And subscribe to my channel here. And subscribe to my other channel, Artzilla Pencil, where I teach art, that is linked here. Thank you and goodbye until the next video.